Task 5, Exponential Functions and their Graphs. Example 1. Plot the graph of y equals 5 to the power of x for x between negative 2 and positive 2. State the y-intercept and write the equation of the horizontal asymptote. So in this exercise we're mostly just plotting the graphs, which means get a table of values, and then once you've got all your values you can plot the points on the graph and join them up with a smooth curve. So the first one is x equals negative 2, so you substitute negative 2 into the equation, and that'll give you 1 on 25. If you prefer, you can write that as a decimal. And you just continue that process on, just substituting the x value in. You can check it on your calculator. These are the values that you will get. And so now we can sketch the graph. So make sure you're using a ruler to measure the points evenly and set up your scales. You don't need to have the same scale on the y-axis and the x-axis. So it's okay that I'm going by 1s on the x-axis and 5s on the y-axis. Now the first 3 points are difficult to sketch. They're very close to 0, but not quite 0. So the first one at negative 2 is 0.04, so it's very close to the x-axis there, and so is the next one, and even the third one. But then it starts to increase. At 1, x equals 1, the y value is 5, and x equals 2, the y value is 25. So an exponential graph looks like this. It starts off quite flat, and then gets steeper and steeper. And we should label our y-intercept, which is 0, 1. And this graph has what we call an asymptote. An asymptote is a point where the graph gets very close to, but never touches. And in this case, the asymptote is the line y equals 0. So the graph gets very close to that line, but never actually touches. So I've put in a dotted line here to show where the asymptote is, and I'm going to label it as y equals 0. So before we move on, let's just clarify the definition of an asymptote. It's a line that a graph approaches or gets very close to, but never touches. So the one on the left is getting very close to the line y equals negative 3. And on the right, the first graph, the blue one, has got an asymptote at y equals positive 3, and the red graph has got an asymptote at y equals 0. Example 2 is very similar to example 1. Can you please press pause and try this one on your own? Okay, they're asking us to plot, so let's do a table of values. In this case, the table of values goes from negative 3 to 3. And when you substitute into the equation, this is what you should get. It's okay if you did decimals instead of fractions. And now we're ready to plot the graph. So draw up your axes. Of course you'll use a ruler to measure these properly. And now you're ready to plot your points. So the first one is x equals negative 3, y equals 8, negative 2 and 4, and so on. Once you've got those, join them up with a nice smooth curve. Now the y-intercept, it's important to label that, is 0, 1. And the asymptote is y equals 0, and I'm going to show that with a dotted line. So there we have our graph. Example 3. The number of bacteria, n, in a culture at time t minutes is given by the equation n equals 200 times 2 to the power of t. So that's an exponential equation because the variable, in this case t, is a power. Part A, find the initial number of bacteria. The key word there is the word initial. Initial means at the beginning, so in other words, when time equals 0. So what we're going to do is we're going to take our equation and we're going to substitute t equals 0. Now 2 to the power of 0 is 1. Anything to the power of 0 is 1. So at the beginning at t equals 0 there are 200 bacteria. In part B we're asked to complete this table, and we've already worked out the first one. And to find the others, you're just substituting the t value into the equation. So the next one is 200 times 2 to the power of 1, which is 400. Then substitute t equals 2, and so on. And now we're ready to plot the graph. And so now plot the points. There we have our graph. Now, don't extend the graph backwards because this has got a very definite beginning. The graph begins at time equals 0. We're not going to have negative time for this question. So the graph starts right here. That's the end of the video. Good luck with the exercises. Hooroo!